So for today's notes, the 4-1 solving system of equations by graphing. The I can statement is I can use graphs to find approximate solutions to the system of equations. So we want to remember approximate means about, and solutions means answers. So there are going to be 3 possible answers. And if you notice on the bottom, these are examples of what your graphs could look like. On the left, on the bottom left, it's where the 2 lines intersect. So they intersect at one ordered pair and one ordered pair only, and that's called one solution. So your answer is going to be one solution, and then you're going to tell me the intersection, the ordered pair, x comma y. In the middle, if you notice, this is kind of a review. They're parallel lines. Parallel lines, as we learned in topic 2, don't intersect. They have parallel, they have the same slope, different y-intercepts. So they are not going to have a solution. So really, you write no solution because they don't intersect. And then lastly, on the right, infinitely many solutions. It's when I give you 2 equations and they actually are the same line, same y-intercept, same slope. So we call that infinitely many solutions because every ordered pair on that line is a solution. Now, for example 1, it says, what is the solution to the system of equations? So we want to recall that our m is -2 and our b is -4. And then I'm going to use a different color. For my second equation, my m is going to be 1/2, and my b is going to be 6. So I'm going to use Desmos to draw the line. So I'm going to begin at -4. So I'm going to plot a point. And then the slope is -2, so that means go down 2 spots, right 1, put a point. Down 2, right 1, put a point. Now it's important for you to know you want to fill this entire grid because you do not know where my blue or my red line are going to intersect. So the opposite of down 2, right 1 is up 2, left 1. So then you just keep going. And notice that they have a line right here. You want to use the line tool. I do not want you drawing the line by hand. And then I'm going to change my color to red. I actually like using the line tool to plot my point too, because it kind of gives me that crosshair. Up 1, right 2. Just going to click. I'm going to do that until I run out of room as well. And then I'm going to go backwards. Notice right away my line intersects, which is cool. That's what we want. But I'm going to keep plotting the points, and then I'm going to draw my line. Now they intersect at an ordered pair. For right now, I'm going to give you nice whole numbers. So they intersect at -4, 4. Remember, it's x comma y. So then that's what I want you to type. It's one solution because they intersect at -4, comma 4. Now the second equation is going to be the same. So I have y equals -1, I'm sorry, the second problem. So y equals 1/2 x minus 2. So I'm going to begin at -2, and then I'm going to go up 1, right 2. And I'm going to keep doing the slope over and over again. And then I'm going to do the opposite. So I'm not even using my pen anymore, I'm just clicking with my mouse. So you're going to notice that that is going to be super easy for you. I'm going to click on the line, extend it from point to point. And now I'm going to switch colors. I'm going to begin at -7 this time. And now I'm going to go up 3, right 1, because the slope is 3/1. Notice that it's the intersection, but I'm going to keep going so my graph extends through. And then, where do these two lines intersect? Remember, it's x comma y. So it's one solution. The x is a +2, and then the y value is -1, because you have to go down 1. All right, for the third one, it's y equals 2x plus 10. So I'm going to begin at 10. Now notice I can't go up to right 1, so I just have to go the opposite, down to left 1. So when you can't do any room to the right, you just go backwards. Notice that it's a positive slope. If you went the wrong way, it would be a negative slope. So just be very mindful of that. All right, so I extended it all the way through the second and third quadrant. Now, +1 is my y-intercept for my second one. And I'm actually going to choose a different color. Now, -1/4. Remember, just throw that negative on top. So that means I'm going to go down 1, 1, 2, 3, 4. Down 1, right, 2, 3, 4. Ran out of room, so I'm going to do the opposite. The point. Sorry, my cursor is going. Okay, see, I can already sense that I made a mistake, and I made a mistake right here. Notice that these are equal intervals, and then this one's just a little bit off. It is because I did not go 4, I went 3. So 1, 2, 3, 4. All right, so now I can plot my line. And once again, this one intersects at -4. So -4, and then I went up 2. So the ordered pair would be -4, comma 2. Now for example 2, this is where it gets a little bit different. You want to remember that we should have this in slope-intercept form if it's not. So the first equation is not. Let me see if I can draw this better. So I have 15x plus 5y equals 25. Now this is where we did from topic 2. We're going to minus 15x on both sides. Now notice I'm putting the minus 15x on the side because 25 are not like terms. We did this for bell work a lot in November and December. I'm going to put the negative 15x first. The 25 was positive, so we're going to add 25. And then the last step is to divide everything by 5. So then I have y equals negative 3x, because negative 15 divided by 5 is negative 3. And then 25 divided by 5 gets you 5. Now that's our first equation that we're going to graph. So I am going to begin at 5. And I'm going to go down 3, right 1, down 3, right 1. And then I'm going to go up 3, left 1. And I'm going to draw my line. Now I'm going to go back up, and I'm going to look at the second equation. The second equation, hey, look at that. It's y equals negative 3x plus 5. Well, guess what? We already plotted negative 3x plus 5. It would be identical. So if you notice that you are plotting a point, and I should have done more on this line, begin at 5, go down 3, right 1, down 3, right 1. I should have extended this, sorry. 1, 2, 3. If you extend it and your lines are overlapping, that is special. That is infinitely many solutions. So it is infinitely many solutions because the lines are the same. You could say it is infinitely many solutions because the lines overlap at every point. So you don't have to write both of them. You can talk about that. You can do something along those lines. So I just want to give you 2 different ways of getting the right answer. All right, now for this one. It says, what is the solution if you have y equals 2x plus 6? So I'm going to graph that up to right 1. All right, go all the way. Draw your line. And then your second equation is 2x minus 8. So now we have a different y-intercept, but the same slope. So you should remember from topic 2 or from the notes previously that these are going to be parallel lines. They're never going to intersect. So you can move to the previous slide to figure out what that answer is, or you can just remember or think about, since they don't intersect, that means there's no solution. So these are 2 parallel lines. You can say the lines are parallel so they don't intersect, which is no solution. Something along those lines or those words are fine for the explanation. All right, so the triads. Notice right here we have one equation that we have to change. So we have the 4x minus 8y. So we have the 4x minus 8y equals 12. So we're just solving for y so we can graph it. Minus 4x on both sides. Remember the negative sign, that negative 8y equals negative 4x plus 12. And then we have to divide by negative 8. Okay. So once we get this, we are going to have y equals 1 over 2x. And this is kind of silly of the book to give you a decimal for the y-intercept. I actually don't agree with this, but you'll have negative 1.5. So just do your best. On a test, I will never give you a decimal for a y-intercept. So just plot it right in the middle. Actually, sorry, that should be a negative 1.5. So negative 1.5. And then you're going to go up 1 over 2, up 1 over 2. So you're just going to kind of stay in the middle. And then you're going to go down 1, which is still in the middle, left 2, down 1, left 2. You're going to do your best. Like I said, I won't give you a decimal like that. That seems kind of silly. But what you should notice, if you go back up to the problem, you should notice that it's the same slope and different y-intercept. So the original equation, or the first equation, is y equals 1/2 x plus 7. So I'm going to choose a different color. So I'm going to go to 7. I'm going to plot a point, up 1, right 2. So this should be semi-easy because we've already done this slope. You're going to notice that since it's the same slope, different y-intercepts, they're parallel. Now go back and look at your notes in the previous slide and see, or previous problem, that since they are parallel, they never intersect, which means no solution. Okay. And then the last problem, you're going to have to do the same math. So we're going to have to change the first equation, and sometimes you change the first, sometimes you change the second, sometimes you have to change both of them. All right, minus 3x on both sides because it was a positive 3x to begin with. Sorry, that should be a y. I don't know. My pen does not like to work. So negative 3x plus 6. So then we're going to divide everything by 2. So then we have y equals negative 3 over 2x. 6 divided by 2 is a positive 3. Now, if you notice, the work that we just did for the first equation is identical to the second equation. So that is awesome. The reason why it's awesome, you only have to graph it once. It's the same line. It's like I was trying to trick you or something. So when you have the same line for both equations, all you have to do is graph it once. So I'm going to begin at positive 3. Go down 1, 2, 3 over 2. I'm going to keep going. 1, 2, 3 over 2, over 2, so on and so forth. And then do the opposite. So 1, 2, 3 over 2, 3 left 2. And since my lines are the same, I'm only going to do this once. And you just write that in your answer. The two equations given are the same, so that means it's infinitely many answers or solutions because it's the same line. So something along those lines work. So once again, you're going to have three different types of answers. One solution is when they intersect once, and you're going to tell me the ordered pair. No solution is when they're parallel. Same slope, different y-intercepts, they're never going to touch, so that's no solution. And then infinitely many solutions is when the two lines are really the same, and they're going to intersect at every single point on that line.